Somewhere in the darkness between stars, NASA's most powerful telescope pointed at the edge of time and found something that broke every rule we thought we understood about the universe. Not a faint smudge, not a primitive cloud of gas, but massive, fully formed galaxies, blazing with billions of stars, existing at a moment when the universe was barely a toddler. The physics said they couldn't be there. They were there anyway. To understand why this matters, you need to picture the universe as a story with a very specific opening chapter. After the Big Bang, 13.8 billion years ago, everything went dark. Literally. For hundreds of millions of years, the cosmos was a cold, silent ocean of hydrogen gas. No stars, no light, no structure. Scientists called it the cosmic dark ages. And from that darkness, gravity was supposed to slowly, patiently sculpt the first tiny, fragile galaxies over billions of years. That model wasn't just a guess. It was built on decades of observation, mathematics, and the most sophisticated simulations humanity had ever constructed. The Lambda CDM model, the standard framework of cosmology, predicted small, dim, scattered galaxies in the early universe. When Hubble looked deep into space, it confirmed exactly that. The further back you looked, the smaller and fainter things became. The theory held, until Webb arrived. The James Webb Space Telescope launched on Christmas Day 2021, carrying a mirror nearly 3 times the size of Hubble's, coated in gold, engineered to catch infrared light that has traveled billions of years across an expanding universe. Webb wasn't just an upgrade. It was a fundamentally different kind of eye, one capable of seeing things no instrument in human history had ever reached. Scientists aimed it at the earliest moments of cosmic time, expecting to confirm what they already believed. They were not prepared for what came back. The images revealed galaxies so large, so luminous, so structurally complete that they shouldn't have had enough time to form. One candidate galaxy appeared to contain as many stars as the Milky Way, but existed when the universe was only 500 to 700 million years old. Under the accepted model, that's like finding a fully grown oak tree 3 days after planting the seed. The numbers didn't add up. The timeline didn't add up. And yet, there they were, undeniable in the data. Astrophysicists scrambled. Papers were published. Conferences buzzed. Some researchers suggested the galaxies were forming stars at rates hundreds of times faster than anything previously observed, a kind of cosmic sprint that the standard model had never predicted. Others proposed that dark matter behaved differently in the early universe than current theories assumed. Every explanation raised new questions. The more scientists looked, the more the early universe refused to behave the way it was supposed to. Then came the numbers that truly unsettled the field. Early estimates suggested these massive early galaxies were roughly 10 times more abundant than models predicted. Not slightly more common. 10 times. That's not a rounding error. That's not a calibration issue. That's a signal that something fundamental about our understanding of galaxy formation, perhaps even about the nature of dark matter itself, may be incomplete or wrong. Here is the twist that reframes everything. The James Webb Space Telescope was built to confirm our model of the universe. It was designed to fill in the final details of a story we thought we already knew. Instead, it handed us a completely different story. The telescope built to answer our deepest questions has, in its very first years, generated questions we don't yet have the language to answer. Science rarely works the way we expect, and that is exactly what makes it science. This discovery matters not because it unsettles astronomers, but because it unsettles certainty itself. Every generation believes it has nearly figured out the universe. Every generation is humbled. What Webb is showing us is that the cosmos is stranger, older feeling, and more complex than our best minds imagined, and that the willingness to be wrong is the most powerful tool humanity has ever developed. That humility, that hunger to keep looking even when the answers surprise us, is what separates curiosity from comfort. Subscribe to factstormhub. We tell stories like this every day. Full article on factstormhub.com.